So while Chris is getting set up, let me introduce him and Jonathan Berry. Jonathan Berry is joining us on the Zoom call here. Jonathan Berry is the founder and CEO of Golioth, a straightforward commercial IoT deployment platform built for scale. Jonathan has spent more than a decade building IoT solutions at companies such as Google, Nest, Particle, and WeWork. If you really want to get him going, which might be difficult since he's remote, ask him how he would build a real holodeck. Chris Gamble, who's here, is an electrical engineer, podcaster, and a design consultant from Durham, North Carolina. He has over 20 years of electronics design experience working for companies in the industrial, silicon, communications, and test and measurement devices. His main work is a DevRel lead at Golioth, an IoT SaaS startup building infrastructure for IoT deployments. Previously, through his work at Analog Life Consulting, he created hardware and firmware designs for clients ranging from connected sensor networks to variable performance tracking. He has been running the AMP Power podcast for more than 10 years, and a weekly hour-long show discussing trends throughout the modern electronics design industry, something I'm looking forward to listening to. Chris has taught hundreds of people how to design electronics via his online course, Contextual Electronics. Started in 2014, it focuses on teaching electronics design skills for beginners and intermediate students. Chris got his bachelor's degree in electrical engineering from Case Western University.
Sorry about the delays, everyone. After 2 years in the pandemic, audio and video is still hard, right? And I can't hear anyone. So if there's any questions that pop up in the middle, Chris, just let me know, or Rusi can text me. But thanks everyone for your patience, and excited to be here virtually. We're very excited to share what we've been working on at Golioth. And really, the topic today is about device management and bringing that in a new way to Thread. We had a short intro, but I want to say hi real quick. My name is Jonathan Berry. I'm the founder and CEO of Golioth. Very, very familiar with Thread, and back in the day, I was involved with OpenThread and the Thread group. So many familiar faces I see on the Zoom, but for those of you new to me, and hi. And you already met Chris in the audio side. He'll be presenting on the second half of our talk. With that, we'll get right into our presentation. Try to go a little bit faster because we lost a little bit of time. So I want to start out talking about some of the challenges we've seen deploying Thread networks. And this is not going to be an overview of Thread because everyone in the room knows what Thread is and some of the capabilities, but really to set the context about device management as it relates to Thread. One of the unique aspects of Thread deployments, as opposed to other types of IoT products, is they tend to be large. In sort of other types of IoT devices that may have a direct connection to the internet, a company or a product manufacturer might be dealing with single endpoint devices, standalone devices that are fewer in number. And so that means they are easier to manage. Maybe you have a couple dozen devices, all with their own IP address and connection to the internet. So you could build your own solution, maybe homegrown, some device management software within your own engineering team, maybe go outsource it with another company. But when you start to talk about Thread scale, tens of devices, hundreds of devices, thousands of devices, or many deployments with many devices in a network, that becomes untenable for a homegrown solution or for more classic traditional device management. So you need something really that is scalable to meet the deployment size that you see in Thread. The other aspect is Thread devices are small or resource constrained. And we typically refer to those as the endpoint devices, the sensors in the field that are monitoring or creating access control. And while there is more traditional device management, or also known as MDM, it isn't designed for IoT. They use protocols and management software that was designed for servers and cell phones and laptops. And that won't work for a resource-constrained device like a microcontroller out in the field. And when it comes to the cloud aspect of doing remote device management, there are certain categories of challenges that we see as well. When we're just talking about connecting to the cloud, like sending some sensor data over a Thread network across the big internet to maybe create a dashboard, that whole end-to-end cloud connectivity Well, the thread side is already handled by the thread protocol and implementations, but going across that barrier is a whole mountain of complexity. And doing the other direction, for example, unlocking a door lock, has a reverse problem and sometimes even a unique set of challenges. On software updates, it's even harder because we're dealing with unreliable networks across the thread network, as well as its connectivity to the internet, different size of networks. So maybe you're on a NB-IoT, constrained cellular network, where you have a very small pipe. So you have to manage your software update very carefully. Or you're on an Ethernet industrial controller, and you have to now match the connectivity from Ethernet down to a device. And of course, you're dealing with batteries. So the challenge of actually managing that software update and implementing the software update is uniquely hard when you're talking about going from the cloud to a thread device. And lastly, remote monitoring, which can actually be true big data. And that is monitoring the health and reliability of the thread devices in the thread network. Could actually be even more data than what's generated by your sensors. And keeping track of where the remote monitoring data is coming from, which device, being able to use it later is a whole class of problems that is honestly dedicated by specialized software companies who just do remote monitoring. And so to kind of bring us to what we're working on with Golioth. And generally speaking, Golioth is described as a device management platform, and we'll go into how we do a little bit more than that. And we've been around for almost 2 years now. And if we were to summarize what we do and what we do best is we make it as easy as possible to manage data from devices and the software updates and firmware for those devices. And as an example, we integrate a bunch of capabilities for things like being able to group devices. We call them tagging, and say, I want to update this set of devices at a particular customer site or in a subset of devices in the field, and only push software updates to those devices. And similarly, you can say, I want to just view the data from a certain subset of devices that I'm troubleshooting. And all that is part of our platform, and we'll go into that in more detail and in more specifics for the next 5 or 6 minutes. As part of that, we provide lots of tools. Our most important tool is probably our web app. It's a single pane of glass to allow engineers at companies who are designing and manufacturing the electronic devices, or those who are managing in the field, have a single pane of glass to see all the devices, the status of the devices, take control of those devices, maybe manage the firmware. And Chris will be walking us through our console a little bit later. And of course, we also have APIs and other integration points that allow management at scale. And to go one level deeper, Golioth has 2 other key parts. There's the cloud side and all the services, which I kind of alluded to in the previous slides, and a device side. And starting with the cloud, that is the cloud software that allows you to do management. Things like software updates, things like telemetry and monitoring. And we can talk about classic fully connected IoT devices, but actually, when we talk to customers who just want what we call a little bit of cloud, it's actually just as hard as building a fully always-on connected device. For example, if you're building a local mesh network, you might not need to do software updates, but from a compliance perspective, and this is now laws in some parts of the world, you need to have ability to do a software update in case there's a critical vulnerability. Well, having that maybe one day kind of hope will work OTA implemented and a full end-to-end release once a week, once a month kind of cadence is the same level out there. It's pretty much binary. And, designing that little bit of cloud in takes a lot of engineering effort. And we as a platform want to make that as easy as possible for product creators. The other aspect of Golioth is that our cloud is really focused on IP-based application layers and networking technologies. So out of the box, and previously, we've been supporting Wi-Fi, different forms of cellular, Ethernet, and different application layers like CoAP and MQTT. Well, thankfully, because Thread being IP-based made it really straightforward for us to start doing development and bringing Golioth to Thread. As a data point, it took us about 2 weeks to prototype our very first Thread network with our existing infrastructure. And because we extend Golioth into Thread, that means all the services and all the capabilities of the Golioth platform is now unlocked with Thread, which is super exciting and what we're really here to show off. As an example, I've talked about remote monitoring. We call it logging. And we have a generic service that allows you to log anything about the device, the network, the radio technology. And so in that example, we can take thread level data, like the thread network data sets, and stream it to Goliath's backend for monitoring the thread network. And that was, you're going to see that exactly, I think, in Chris's demo. Very easy to do because of our IP-based protocols and the hooks into our device-side software. Another example is sending sensor data, or what we call stream of data, in time series format to our backend database, which collects and aggregates measurements. Well, that's easily for tying into an end device that might have a temperature sensor or some other kind of sensor for the real world. Again, very trivial to implement because of that IP-based hooks. And lastly, one more slide after this, but we have the probably number one feature of our platform is software updates. And I mentioned tags earlier, how you can not just update one device or a fleet of devices. Well, being able to do that for that large number of thread devices works just out of the box because we have an update mechanism that's end-to-end secure with actually secure boot and secure communication. That just kind of worked. It was amazing when we had that first demo on our desk. I guess the last thing I was almost about to skip over is once you manage your devices with Golioth, we have all these different integrations, what we call output streams, to connect the device data or other application level data to one of our cloud partners. So like Amazon, Google, Microsoft, and others. And that takes the little internet and little devices, so super constrained IoT specific protocols, and make it really easy to stream that to hyperscalers and others. And that just worked. So we can build dashboards and demonstrations that are be able to show off what's happening on a thread network or integrate it into your application. So that's the cloud side of Golioth, and what we talk a lot about. But what enables this is actually the device side, because we're talking about IoT and thread devices. So we call that firmware or the software we provide for embedded engineers to develop their integration into the Golioth platform. With our approach to hardware is we want to make sure that we focus and enable as many devices as possible. And actually, from a device management perspective, we probably support the most number of platforms out there. And when we started this journey of adding thread to our solution, we wanted to make sure that we can support as many thread devices as possible. And our initial focus is nodes and endpoint devices, things like sensors and routers. We'll talk about border routers in another time. But we believe that the best opportunity is for us to enable as many use cases as possible with the best possible hardware. And part of our implementation is built on Zephyr. Zephyr is a real-time operating system. It's an open source real-time operating system from the Linux Foundation. Golioth is a contributing company, a member company, and we allow our users to take any device that's supported by Zephyr, which is over 400 different types of hardware and hundreds of types of modems and connectivity, and connect it to Golioth. So as long as it has an internet connection and an IP bearing capability, well, then it would work with Golioth. And so that obviously made our support of thread that much easier. And the neat thing for us is Zephyr today supports thread out of the box, and it's well supported by the Open Thread project. And so by enabling Open Thread with Zephyr, and our integration on top of it allows us to unlock all the different devices and capabilities that already exist in Zephyr via OpenThread. So every device that's supported by OpenThread vis-a-vis Zephyr is now supported by Golioth, which is awesome, and us standing on the shoulders of giants. To kind of give you a quick update on the status, we are currently working with chipset vendors who happen to be member companies. I think Chris has some of the hardware that will be familiar to some folks there. And we're working with more who are interested in using Thread with Golioth. We have our working end-to-end implementation, which we have on stage in front of you all. We are now working through productionizing that as making part of our official SDK. And we're actually actively working with different customers who are interested in Thread, and actually Thread plus Matter, but that's for a different member meeting. Both in the consumer space, which we know is pretty interesting and popular, but actually commercial use cases, which we're excited and see the tremendous value that Thread brings to commercial customers. I think with that, my part of the talk is mostly done. I'm going to hand it over to Chris, and hopefully audio and other issues aside will be in his favor. So take it away.
Here. Hello, test. Can you guys hear me? I muted the computer this time.
Yeah, I have this up.
A little higher. Okay, great. All right. So Jonathan, you are muted, just so you know. Oh, and you muted yourself. Awesome. All right. So because of the space constraints here, I'm using the wonderful webcam software that we have available to us. So pretty basic setup here, right? So I brought a, this is the open thread demo that we kind of just went through, got started, bootstrapped up, that sort of thing. And so this Raspberry Pi in front of me here, well, I'm gonna keep that like that. Running as border router, has a NRF52 dongle in the back as an RCP. We have an NRF52DK as the node device, currently set as a router. This is the leader, of course. And so for people that might only be watching, that's what this looks like. And the dongle, that's what this looks like. And so, yeah, we're already in that status there, we're already connected. Brought also a huge battery because, well, this is a good example of why you want to have, when you have constrained devices, you want tiny batteries, right? You don't want to have to bring a full Linux device. I'm very excited about all the border routers that are coming out, so we can just start using, not making our own, we can just start using other people's. With that, I'm going to go back to this presentation maybe, and because I think, hopefully this shows up okay. And so, okay. Oh my gosh, that's huge. Okay, we're gonna rely on this stuff. Okay, so what you can see though is currently we are online because we actually have formed this thread network. We just have some, so this is the actual device management dashboard here. This is called our console. And I'm going to walk through a little bit of this here, but the first thing I'm going to show you is the actual individual device view. So again, this is this device here connected through the RCP that's formed a small thread network. This is then forwarding packets along so that this IP address is again available to the Golioth cloud. And then, so within this Golioth, with this console that's showing us offline, that is probably the wrong, oh, let's see if I reload this here. I'm not liking that. All right, let's hope for the best, or else I'm switching to the video. Okay, so this is a detailed device page, right? So you might have 100, 1,000, a million devices out in the field, but each one you want to be able to specifically target, and you're going to have some kind of identifiers with it, right? In this case, there is a timestamp based hardware ID. You can put in your own hardware ID based on a UUID that might be buried in silicon. That all comes down to the provisioning process. We then generate other unique identifiers here as well. But at the end of the day, if you have, say, 1 million devices out in the field, you want to know that the device in your hand is the one that you're looking at on screen. You have some identifiers, maybe you have some feedback mechanism that shows as you click a button, you blink a thing. Then now we know we're looking at the correct device here. Hopefully it shows us is online at some point here in the near term. And then we have other things in here. So LightDB state, LightDB stream, I'll talk about these in a second. The real part of the demo here, which again, hopefully goes, this is basically from the Zephyr logging that is on this device. So this device, an NRF52, is running Zephyr, the real-time operating system. It's got the open thread stack on it. It also has at the top layer, it has the Golioth SDK in there, which then tells at that top level networking stack how to communicate with Zephyr and how to pass along all of those logging messages, because the Zephyr logging is tied into the Golioth APIs that can accept logging messages. So, and then these are kind of all displayed here. So in theory, if I hit a button, we will see some updates here. Oh, hey, all right. Yeah, live demos. And you see the timestamp here. So basically, as I'm pressing buttons here, what's happening is this device is registering a button press internally on the silicon. It's then logging a message, as you might do to a UART normally. That is done in Zephyr logging. So you could, if I pulled up my UART console right now, because this is actually also plugged into my computer, you would also see these messages showing up on that UART console. That's then getting forwarded along the thread network through the border router up to Goliath. And because it's just, IPv6, we know how to accept those messages. And then each of these is then displayed on the logging here. So again, just pressing buttons, showing an output, right? It's like this kind of very simple light switch style demo, but you'd expect it to work on every device. And just think about all the layers and all the work that you all have done to get us here. It's very impressive. So so that's just that one portion here. Other things that you might want a device to do, like again, just an NRF52, little Bluetooth and/or Thread and/or all of the things that NRF52s can run. You usually want to have sensor data, right? So actually, we'll go to sensor data in a second. Another one is command and control. And so we have a concept called LightDB state. And this is basically a flat database that you can just define yourself here. So you say, and this is kind of the language of the web, JSON style thing. So, a key value pair, LED 0 equals true, or LED 0 colon true. And then that message then gets passed all the way down to this device. And then there's a listener in Zephyr that says, hey, this new value has arrived. It may actually even be encoded along the way. So one thing that we integrate in our SDK is CBOR for helping compress stuff down. We also use CoAP as the transport protocol. I'm just making sure if Jonathan's not shaking his head violently to see if I'm saying anything wrong here. And a hardware background, if that wasn't clear. So all the web software, everything else, I'm learning day by day. So basically though, if you wanted to then turn on an LED or you wanted to actuate a motor, you would do that in LightDB, maybe on the console here, but even more powerfully through a REST API that you're basically, you have an app, you call you do the REST API call, and then that gets pushed all the way down to the individual device. Now going the other direction, if you're doing sensor data coming off of this thing, so say you wanted to do temperature data, you could start to publish that over something called LightDB Stream. And that's a time series based database because you want to not just know what is the current temperature and have that updated dynamically. You also want to know what it's been historically. And I'm going to show you just some data from another device, but we have a LightDB Stream thing here. So this is actually from a Stream Thingy 91, which is another Nordic device. But just to show a wide array of data here. And so basically each of these individual things is data coming off a sensor being registered. And then we have different ways to showcase this. Again, this is on an individual device view. So this is just one Thingy 91 that I have actually in my bag with the wrong firmware on it. But it pushes all this data back to a time series based database. And then you can, you could parcel up the data here to be able to make it easier to view kind of in a live manner. But this is just a holding cell for it before you want to possibly push it out to other places, like maybe a AWS SQS queue or a Event Hub or a output stream. And that's what Jonathan was talking about here with output streams. We basically, in terms of pushing out to a new type of output, you might want to do that here. And so you start to register an AWS SQS output thing, but you want to then say, well, I only want to know when the device firmware has been updated successfully. So you have this hyperscale thing out there. You want to know every time your fleet of devices has successfully pushed to a new firmware version. You've got 1 million devices. They all go from 1.00 to 1.01. You just have this one widget living in the cloud, and that basically is listening for 99.8% of all devices have successfully updated. Then you can start to go and diagnose at that point on a hyperscale. On an individual scale, if you wanted to go and look at these firmware updates. So this is actually what the firmware update looks like. We have a concept of an artifact. So this might be just the firmware update for this device here, right? So a Zephyr, a new Zephyr firmware version, built with MCU boot, which is the bootloader. You basically sign it so it's secure going down to the bootloader as well. You put that firmware version into it here as an artifact. You bundle it up as a package, or as a release rather, and then you go and you literally just click, you can't see it on this view, roll out and roll back. And basically you can roll out 1.01. You say, actually, that wasn't the right thing. You roll it back to 1.00. Like Jonathan mentioned, you can also have tags as well. So, we can tag things for different, Internet of Cows. Of course, you have to have that one on a demo. Testing, you might have different sites that you would tag for. So you have your manufacturing site where you're only testing some portion of your fleet. You have maybe just your deployment region. So you're just testing in the Pacific Northwest. And so you could go and target things there as well. This is a very, it's a very flat database style because it's a tagging thing, but you can build up your own set of criterion for what you would want to deliver a new firmware package to. So as you're testing, again, everything you're seeing here, this is a console, but this is all built on top of our REST API. So basically, someone could replicate this internally. They could go and build their own REST, or sorry, their own web interface. They could work with us if they wanted to, borrow from this and build a management interface that's on top of our REST API. All of that is basically because this is a device cloud that enables all these things. Just making sure I didn't miss anything here. Output streams, API keys, users, user management. That's another thing too. As your teams grow, you might want to have different levels of access as well. That's another thing in there. I think I covered all of it. Let's go back to the presentation, I guess. Right. I'm going to turn my mic off.
Is on. Can you hear me? I can't really see. I don't know why I asked. Oh, sorry. I guess I'll wrap us up pretty quickly. Chris walked you through all the capabilities of our platform, and really to set the context that all those features like software updates, device logging, now works with Thread via Golioth, and we're pretty excited. We showed off one hardware set from one of our hardware partners, but we actually, thanks to Zephyr and some of our enablement, have a whole hardware catalog of devices, including Thread-enabled devices that can be used with Golioth, and we're excited to add more partners over time. We talked about output streams, and Chris even kind of teed up that we have turnkey integrations with companies like Amazon, Microsoft, and Google. But we also have partners that do data visualization and dashboarding and even simplifying app creation. And so the TLDR is you can build your entire application with a device management platform like Golioth and cloud enablement for data visualization without having to manage any servers. And this is all already built, integrated, and is a simple development process. As the last thing, in the few minutes we have left, we are a fully available platform. We both have a free tier, so anyone can go out and sign up today and use Golioth for free for life. That works with not just Thread devices, of course, but any other type of radio technology that we support out of the box, like Wi-Fi, cellular, and Ethernet. And if you're interested in Golioth, especially for those who are building products and end devices with Thread, feel free to reach out. Obviously, Chris is there. You can contact us via our sales email or Chris's team, DevRel. And we have a whole bunch of other content out there on social media. Our YouTube channel is technical YouTube video, and we encourage you to come and check us out. And thank you for having us.
All right, getting off easy. I'd love to chat with all of you. If you have any questions, I'll have my demo here. We could poke and prod, try things out. Let me know. All right, thanks again.
Thanks, John.